Hello and welcome to part 3 of the 1946 Packard car radio restoration repair. We've made a command decision here. We're going to go with the oval speaker. I'm not comfortable with the fragility of that paper cone, not to mention it just doesn't sound very good. This will give the radio a long life, and let's face it, we've changed all the capacitors and we're putting a solid state vibrator in there. In fact, one of the viewers commented, you're changing to a solid state vibrator. You might as well go ahead and change the speaker, and this is where I've been leaning anyway, right along. I just want to be able to sleep at night and not worry about that cone shredding itself to pieces. Now you can send that speaker to a place in, I believe it's Tennessee. There's a guy who recones speakers, but it's anywhere from $75 to $100, and that doesn't include shipping it there and shipping it back. And this is a speaker that can be inexpensively purchased. This will outlive the car and its owner probably, as it is. You've got some high frequency response from the little plastic cone here in the center. It's going to have a better balanced sound, and it's going to last. So I think that, well, not I think, I know this is what I'm going with. I printed up a 3D adapter, and that will fit over the studs and cover, the complete speaker area. It will be invisible from, once this set is behind the dashboard and up inside the car. And the thoughts of having that speaker come apart after this radio is installed in the car and they have got to take the radio back out, and no, I'm going with something that's going to be reliable, going to sound better. It was, not a whole lot of effort to program up this adapter. My only concern is I'm adding 0.2 of an inch. This is 200 thousandths thick, just shy of 1/4 of an inch, which would be 250 thousandths. It's setting it back in a ways, so we'll test fit it, and if that's a problem, I can redesign this to work around the outside here. It's a lot more programming to get it to fit on the outside and have a step in it, but I think this is going to work, and we'll try it out here shortly. I've got to clean the rust off of that piece and get some paint put on it, and we'll test fit it, but I'm pretty confident it's going to fit right in there. I don't think I'm going to have a clearance problem. Okay, we're going to set that aside for now and move on probably with the RF alignment of this set. The knob's cleaned up nicely, and again, the only part of this you see are the knobs. Everything is hidden behind the big chrome part of the dashboard. Just this piece appears through. The tuning is working nicely now, nice and smooth. That's all taken care of. Interesting tuner design. You tune to where you tune it individually. Every knob is a tuner. Each one of these has a little wheel on it, and when you have it, it will tune from one end to the other, and you just tune this little knob to tune your station in, and there it stays. You tune each one individually. Interesting design. This middle one is much easier to deal with. Probably put that on your favorite station because they drift a little bit, and every once in a while you've got to tweak the tuning. These plastic, let me get this off of here, these plastic shells are all cracked. He says he has more knobs. These stay on pretty well, and there's not a lot of stress on them. This one, because you have to push it in, and this piece was falling off, so I put some of that light curing, UV curing, near UV curing adhesive in here, because the plastic will transmit the blue light. And then I just shined the UV light around it slowly and cured that adhesive, and now this is well and truly attached to the shell, so that won't fall off anymore. It will always have the crack. There's nothing you can do about it, but it's on there securely. Okay, let me get set up to do some RF alignment. We've got to do the RF alignment on this set, and then off camera I'll deal with the rust and putting some paint on here. Nothing much I can do about this piece, but we'll mask it up. We'll get some paint on here so the set's presentable before it goes in, just to cover up the dirt and the rust and, you know, make it look a little more presentable. This piece, like most perforated sheet metal, is oil canny. When I got out of the Army, I worked for about 2 years in a shop making this type of stuff, and this is just the way this stuff behaves. Now, you can work it and work it and work it and remove the oil can, but it doesn't hurt anything. It doesn't impact the sound. It doesn't impact the, you know, you can't really tell. It's going to be behind the dashboard, so I'm not going to worry about the oil can. We'll get some clear on here to, you know, after we sand the rust off, to stop it from re-rusting. We'll spray some brown on here to, you know, clean it up. We'll clean out everything, get it sanded, and then we'll mount the speaker in there. But I think right now I'm going to do the RF alignment. We'll move into that and take it from there. So stand by. Okay, this was eating at me. I know we're supposed to be jumping into the RF alignment, but it's been eating at me. Is this speaker going to fit? This is probably the hardest part of working on these old car radios. The speakers are usually shot. When you're working with a set like a cathedral set, if you can't save the speaker, it's not a big deal. You've got all kinds of room in the cabinet, and same with any console type set. These car radios were basically built around the speaker. They're 75 pounds of feces in a 4-pound sack. Now, as big and bulky as this guy is, it fit almost. And I say almost. You see this spot right here? This has been rubbing for its entire life against this part of the shield that's around the power supply, the B+ section. The shield comes up at an angle right here. This is lower or deeper into the set than this part is, and right here there's a downward slope. Mine is hitting in exactly the same spot, and I don't know if you're going to be able to see it down in there, but right here I am contacting the frame of the speaker. I guess my hands are too much in the way. It's almost impossible to get the camera in there to show you. And the magnet, which is not horribly bigger than the electromagnet on this, is hitting against the frame here. And if you look at this guy, there's a wear spot right here where that's been rubbing against the same place in the radio. My goodness. My goodness, my goodness. Now, I have taken the flashlight and peered down through all the vent holes lit up in the interior, and I'm 99% sure I'm missing all the wiring, but it ain't by much. It just barely fits in there. The two connections right here are almost touching a little terminal strip right here. Now I can bend these tabs to point straight back, and then I'll put, you know, my clips on there, so that's not a problem. I can get around that. But I'm thinking I should reprint that adapter I made and move that speaker. I've got almost, if I move these wires a little bit right here, I hope it's all in frame. If I move these wires just a little bit, I've got nearly 1/4 of an inch here. So if I take half of that distance, if I move the speaker 1/8 of an inch in that direction, I should clear the frame here, and I'll clear that shield there. So back to the computer, and we'll do a couple hours of engineering and printing, and I guess we'll throw this adapter away because it's not going to cut it. You know, you could rationally say, well, the original speaker was hitting in those two places. What's the big deal? Well, it'll bother me, is the big deal. So I'm going to go ahead, I'm going to redo that adapter that I made, move that speaker 1/8 of an inch in that direction, and I should clear everything. But man, oh man, oh man, are things tight in there. And we're just going to have to go for it. I was cleaning that thing up. I was going to prime it and paint it, you know, and set that whole assembly aside. And I said, no, before I do this, before, you know, I've got to put this thing in here and make 100% sure it's going to fit. And it doesn't. Well, it does, but not to a point where I'm happy with it. So we're going to take this apart and redo that piece. Alrighty, we have remade the adapter for the speaker. We've moved it down 1/8 of an inch, and it's now centered in the opening in the back, and everything lines up.
One person is in serious condition following a crash on 293 in Manchester.
You hear the buzz?
Authorities say the rollover accident happened yesterday near exit 5 of the highway.
That's not the speaker. It's just that this speaker is efficient enough to shake the whole radio.
2 other people also suffered non-life-threatening injuries.
And that buzzing you're hearing is the ceramic cores on the IF transformers rattling around in their cans. See if I can turn this around here.
The agency recommends keeping a close eye on young children and older adults who can have their health affected by high temperatures. Also, people should drink plenty of water and limit their time outdoors if possible. People can keep up to date on the forecast and advisories that have been issued by going to NOAA.gov. Drivers across New Hampshire are still paying less when it comes time to fill up.
So I think what I'm going to do is,
the average cost per gallon of regular gas is now $3.35.
I'll probably put a bit of epoxy there.
And it's also down 17
or maybe I should use hot melt glue in case they ever have to be opened up. I'll put some hot melt glue in there and just stabilize the cores just right around here at the top.
Out the NBA Finals on their home court. Boston will host the Dallas Mavericks in Game 5 of the NBA Finals tonight at TD Garden. Tip-off is at 8:30 p.m.
It's got an amazing amount of bass and drive, and that's on the treble setting. But it's clear.
Porzingis could return from his leg injury for Game 5 of the NBA Finals. Boston will try to close out Dallas tonight for an 18th championship. Sox and the Blue Jays open a 3-game set tonight in Toronto. Boston's in 3rd place in the AL East after back-to-back wins. And Paris Olympics organizers say a rehearsal of their opening ceremony boat parade on the River Seine was a success today. I'm Scott Davidson.
Luxury SUVs now come with the luxury of choice.
So what I think I'm going to do is do the RF alignment. We'll get the RF alignment out of the way.
At your local dealer or at mbusa.com.
I've squirted a little paint on the speaker grill here, and it's on the back as well. We're going to get a strike here for sure. After I get all the alignment done, I'll do the same thing to the cabinet here. Just make it look clean. It's not to make it look shiny and brand new, it's just to clean it up. Right now it's grungy looking. We'll take care of that and we'll call this one done. It's working well. Alright, we're going to move on to the alignment here. Okay, I guess I'm recording now. I hate that this camera doesn't give me any feedback. I've shifted the camera over to my left, which is not where I usually have it, and it's so that I can get up to get to the signal generator. which is up over there on that side, on the right hand side here, while allowing us to film in the radio and have a view of the VTVM. So this is going to be a bit awkward for me, at least. They want us to ground pin 4 of the 7B8. Now the 7B8 is our oscillator converter, and the reason they want pin 4 grounded is it shuts down the oscillator, so that when we inject our signal over here at the antenna connector, it'll go through the preamplifier, it'll pass through here, get mildly amplified by this stage of the 7B8, and it'll give us the correct impedance, and using the tube, it'll give us the correct impedance into the IF transformer. It'll go through the 7A7 IF amplifier, and then we'll peak the other IF transformer. Are we in frame? No, of course not. My excellent filming abilities here. So we'll be coming out of the 7B8, and it will go into the first IF. We'll peak this guy. We'll go into the second IF, we'll peak that guy, and then we'll take a look at the actual RF alignment. First, we want to touch up the IF tuning here. So, I am going to ground pin 4 of the 7B8, and it should just shut this thing right down. In fact, I'll be pulling the antenna out, but I'm trying to find the keyway here. Okay, there it is. 1, 2, 3... and there's pin 4. Shifted the oscillator slightly, just to make sure I've got the right pin here. Yes, 100K to ground. And there, we've shut down the oscillator. We're still receiving noise, and that popping you hear is my electric fence controller. Squirrel, I don't know what's a good term. It's just to keep the squirrels off the bird feeders. Let me go over and shut that thing down from in here. Okay, fortunately I can do that from inside using my phone. It's on a smart plug out there. And I've pulled the antenna out because with the antenna in, that buzzing you're hearing right now is the unshielded radio radiating out to the antenna, the vibrator hash. But with that unplugged, you can see the interior shielding of the radio is pretty good. You can barely, I got it all the way wide open, you can barely hear anything. Now I've got to swing this around to get to the antenna connector and the IF transformers, and you can see where I've locked in the ceramic cores. I put a little drop of hot melt glue there and then went over it with the heat gun, and so that it's nice and smooth and in a little well right there. Should those ever have to come apart, it'll be a piece of cake, and I know I'm going to catch a ton of flack for doing this. The little spring that's in the bottom is pushing the ceramic core up against the top, but it just doesn't have enough force. When the bass notes hit, these cans start wiggling, and it's just causing the cores to vibrate. This doesn't hurt the IF transformer in the least. It can still be taken apart if anybody ever has to get inside it, and it's going to eliminate that rattle, that buzzing sound when the bass notes hit. Okay, we've got our 0.05 here. Right now I got about 10 microvolts on the signal generator. And, oh, this is supposed to be up at 1600 on the dial. That's down this end. Okay. And I'm not hearing anything. Oh, it's there. Very weak, but it's there. Good, we want it weak. Now, what I don't know is, are the screws in this IF transformer hot? You've got to be careful. Some sets, the B plus, is on these screws, and if you short them to ground, you can do a lot of damage. So I'm going to go on DC volts here. We're on the 500 volt scale. Let's see what we got. Nothing. These are cold. Yeah, we'll go down a couple of ranges. There's 50 volts. Okay, good. That means they're cold, and I don't have to worry about them short-circuiting. Where's my tuning tools? I'm so prepared. Let me go grab a couple of diddle sticks here. Okay, because these I know for a fact now these are cold and I can't short anything, I'm going to use a regular screwdriver because these are probably rusty. Oh yeah, I can't. There it goes. Okay, we picked up a little there. I'll put the VTVM on it in a minute. That peaked a little bit. That one seems like it was on the money. And that one was pretty much on the money. So we got a little bit out of these two. Well, let me get the VTVM hooked up. Good grief, I don't know if that thing was recording or not. I thought I pressed the button, but the screen blanked out. I thought I'd turned the screen timer off, and I've still got a full battery. Alright, we're hooked up to the VTVM. I'm going to do this again just in case it didn't get caught. I don't know if we're going to get anything else out of here. We didn't when I did it, when I thought the camera was on. It's pretty much peaked. I think we nailed it before by ear. Only one of the transformers was off. Oh, I got a tiny bit out of that one, I guess. Not enough to really make any difference. Alright, that's that peaked. Now, I've got to go through the RF portion. So, let me get set up. Okay, per alignment instructions, I have put a 30 picofarad capacitor from the antenna connector to the chassis ground. What this is doing is emulating the capacitance of the antenna. Because when you plug the antenna in, the antenna has some capacitance, plus its coaxial cable has some capacitance, and it's so we can set this trimmer to a value that's fairly close to correct. And what you're supposed to do is, after the set's installed and the actual antenna is plugged into the side, there's an access hole in the side of the chassis or side of the frame of the radio that allows you to get to this trimmer, A7 right here, and you tune to 1400 on the dial, or a station as close to that as there is in your local area, and you just go for peak signal, peak volume by adjusting this. But by using a 30 picofarad capacitor here, this should be pretty close. And then there's a 20 picofarad capacitor just to provide more isolation from the signal generator. I'm going to be injecting my signal here, and they tell us to put a 20 picofarad here. And again, that's just to isolate the signal generator so we don't unbalance this too badly. So I'm connected. The capacitors have been soldered in, and right here, here's my 30, here's my 20. I'm going from the chassis ground to the antenna connector, and then from the antenna connector we've got our 20 picofarad here that we're going to feed our signal into. Then we tune to 1600 on the dial, and we adjust this RF coil right here, which is this guy. Then we go to 1400 on the dial, and we adjust the oscillator. Excuse me. Is that right? Let me see here. Adjust A5 for maximum at 1600, and that is A5. Yep. And then we go to 1400, and we tune this guy and the antenna trimmer. We tune both of these for 1400, and then we go to 580 and set the low end of our band with this one. So this, yeah, this would be the oscillator, and these are the two oscillator adjustments, and we've got an RF adjustment. Why don't they have them to do that one? A6, A7. We've got 1, 2. Oh, okay, this is just, yeah, alright, that's just a pattern that goes across. So, we're going to get our generator set here at 1600 kilohertz. And probably can't see it. Frequency 1600 kilohertz. We're still at 50 microvolts. We'll hook up our signal generator. See if we get anything. Oh, I still have the oscillator defeated. I haven't gotten around to disconnecting that yet. Too busy getting prepped here. So our oscillator should be running again. And if I go up to 1600 on the dial, which is where it was, 1600. Oh, wrong knob, dummy. Okay, there's 1600. Then we're going to want 1400, so I'll put that on this dial right here. I'm just adjusting the buttons. And then 680 is almost 700. So we'll do the last one here. That's about 680. Now, why am I not hearing anything? The speaker, well, the speaker came out, duh. Okay. Too many wires, too many wires. Let's bring the signal level up a little bit. Let's go amplitude 100 microvolts. And I'm not hearing anything. So I'm going to try adjusting this guy. Yeah, we got signal getting through. I need to come up with a tool for that. Let me find a tool that fits that little nubbin. Okay, that took a little while. I had to make a tool. I had to find a piece of brass stock, cut a slot in it. These are just little flat-ended things, and I didn't have a tool that would turn it, and boy, this one was jammed all the way to the end. And I put some oil on it, but I'm not hearing anything. Oh, there it is. Boy, that was a long ways off. Okay, there's 1600. The next one's 1400, and it's this one and that one. So we'll go to the 1400 setting. And let's get it right in the center of the 14 here. Sorry about being in front of the lens, guys. Alright, I'm going to change the signal generator to 14. Frequency 1400 kilohertz. And again, I'm not hearing anything. And it's supposed to be this guy. There it is. Is this in frame? Yeah, I guess it is. The volume's all the way up. Where's my screw driver here? Oh, there it is. We'll adjust the trimmer, because that's supposed to be next on the list. Antenna trimmer. There we go. 580. So frequency 580 kilohertz. And this is supposed to go down to 580. Almost 600.
That's impressive, Mike.
Oh, right on the money. So that one's okay. We don't have to mess with that one. Yeah, pretty much on the money. So I'm going to go back up to 1600. 1600 kilohertz or 1.6 megahertz. And let's put this back on 1600. Oh, right there. Oh, I'm turning the wrong one, dummy. And it says to rock the tuning to make sure you're on the center. And elbow in the camera again. Sorry, fellas. Dead center on 1600. So I guess that's just about done. Yeah. Now I could put the VTVM on there, but you know, it's close enough by ear. Turn the volume down a little bit. Let's go to 1400. Which I knocked off by turning the wrong knob here. Let's put this back on 14. Yep, right on the money. And we'll go to 580. Get on the other end of the band. Right there. Okay. Right on the money. Boy, that fell right in. I'm going to go back to 1400 for a minute and just touch up the antenna trimmer. And again, he's going to have to do this in the car at 1400. Not this part of it, but the antenna trimmer part. Because it has to match his antenna in his car. Yeah, that's pretty much on the money for the setup that's here. Okay, that pretty much winds up the alignment. Now what we've got left, I have to install the, let me turn off the signal generator here. Output, where is it? RF off. Where was I going? Oh, we still have to put the solid state vibrator in. That has not come yet. I'm hoping it shows up in the mail in the next day or two. In the meantime, I'll paint this part of the cabinet, get that done, taken care of. The front and the back, as you've seen, are done. But I've got to get in here and mask everything off so it doesn't spray inside the set now. I know I'm going to get asked or told you should take the whole chassis out of there. Too many fragile parts and too many things that are riveted to the frame. I'm not going to drill out rivets and try to redo all of that. Too much of a chance of disaster. Do no harm, that's number one. And it's not about making this look like showroom paint job. It's about making it look clean. So, I'm not going to end this one here. I'll pick this up again when the vibrator shows up, and we'll take a look and see what effect it has on the B+, because as I've discussed before, when I bought this guy from Antique Radio, I lost 30 volts of B+ plugging this guy in, and it's because there's nothing inside of it. It's not, you know, it's not well designed. If you want a good vibrator, a good solid state vibrator, you will have to mount it yourself. You will have to cut open the old can, but you'll have your B+ will be correct. And when that gets here, I'll show you how that's done. I have a complete video on that. It's called, I think it's called Pico RF, or Pico Vibrators They Work, I think is the name of the video. I'll look it up and I'll put it on the screen here, the name of the video, and you can go find that. I went through a bunch of these. I went through a whole, several of these until I found the company that worked. Not a sponsor. I pay for them out of pocket, but you got to go with what works for the customer. Okay, stop yakking, shut the camera down. We'll see you when the vibrator comes in. It's the next day, and the vibrator boards came in, and I went to start this recording, and once again the batteries, or the battery in the new camera was dead. It uses these stupid little proprietary, God knows what they cost, batteries, where my old Canon, the SX20, one of the things I really loved about this camera, or love about this camera, is it uses standard AA's, and they last for hours. And if you're out in the middle of Timbuktu and you realize your batteries are dead, you can run into any 7-Eleven and get AA batteries. These you're not going to find. This camera served me well for so many years, and it still works well. It was such a low resolution, and I'm seeing everybody shooting 4K these days. But at any rate, I guess Canon's got to make their money somehow. It's like printers, you buy the printer for $100 and the ink costs you $2. So the board's here. This is the Pico, and again I have a complete video on these, and you can compare this to this antique radio unit. This has a multi-vibrator chip. It has a quad AND gate that it uses to buffer the multi-vibrator and drive the gate of a dual MOSFET. There's 2 MOSFETs in that package, and that little tiny device right there is doing all the switching. Half of it's doing the switching on each half of the transformer. And this is probably the duty cycle is wrong. It's probably a 50-50 duty cycle where it's supposed to be like a 60-40. And this probably can't, handle the current. It's probably too much voltage drop across that MOSFET. You lose about 30 volts of B+ running that one. Where this guy has 2 MOSFETs, one each dedicated to half the winding, one half of the primary of the transformer. Oh, there's an alert. That's going to set off the guy who can't stand the fact that my phone is on. He was complaining that my phone chirped, and I have my phone set up to my outside doorbell camera, so I know when UPS drops a package off, but I guess it just made him irate. Sucks to be him. Anyway, 2 MOSFETs, 2 individual MOSFETs, one for each section of the primary, and a little controller here, controller chip that operates the on-off duty cycle for 60-40%. You can go to their website, and they've got oscilloscope views of an original and actual vibrator and this thing, and the 2 waveforms are nearly identical. These are available in 2 volt, 6 volt, 6 and 12, which is what this one is. This is a 6 and 12. You can get them in 24 volt. You can get them in synchronous or asynchronous. If you've got military gear that needs an enable pin, this board is capable of doing the enable pin function. The parts aren't populated on this one, but you can order it so that you can have the enable pin. Some military gear, when you go between transmit and receive, it disables the B+ when you're on receive or B, or transmit, I forget. It switches it off and on in one half of the radio between transmit and receive. Very, very versatile boards. Now, they cost, again, they cost the same as this, and you have to build it into your own enclosure. But this unit works. So what I'm going to do is I'm going to desolder this guy, and I'm going to mount some bus bars on this thing. We'll mount this board on that, and then that whole assembly will slip right inside the original can. We'll roll the edge back around, and this will look like a stock vibrator. Now I'll put a label on here that says solid state vibrator and a date, so that, you know, if anybody goes in this set after me, they know it has an electronic vibrator in it. But the points are nearly gone down to the base metal on this. The tungsten's almost gone. This is the one that came out. I did mess with it, and I played around and filed the points and bent the contacts, and I actually did get this to run finally. But it took a lot of effort to get it going, and I wouldn't trust it in the set. There's hardly any tungsten left on the points. It wouldn't be long before it failed again. But these are no longer being made, haven't been made in a long time, so this is your best option right here. So let me get this thing taken apart, get the bus bars mounted up, and I'll show you what we've got. Okay, just a quick recap here. Our 6 volts comes into the center tap of the primary, and we have our 2 windings. They go to the vibrator, and as the reed moves back and forth, you see there's a ground here, so it just alternately shorts this one to ground and then shorts this one to ground. It just bounces back and forth between there. This portion of it is just operates like a doorbell buzzer. The electromagnet pulls the reed up, breaks the contact, the reed falls back down, and it's set up to be resonant at 115 hertz. Now they do that. It's a compromise. The transformer, the higher the frequency, the smaller the transformer can be. So it's fit, you know, it's with a car radio, you space is at a premium. So they want this power transformer to be as small as possible. But you get much above 115 hertz, and it's tough to do that mechanically with a vibrating reed. Now there were some sets, I'm told, I've never seen one that operated at 60 hertz, but I believe they were all pre-war. And that's another thing, the Pico, if you have an oddball frequency, if you like 100 hertz, there's a jumper you can put on that board, it'll change it to 100 hertz. Or if you have something custom like 60 hertz or, you know, something else, they can give you custom frequencies as well if you order them from them. Anyway, all we're doing is alternately shorting one winding of the other to ground and causing a pulse of current. And we have our buffer capacitor here, which helps keep these points from burning up from the back EMF for 1, and 2, it forms a resonant circuit here and makes the transformer a little bit more efficient. Now our board, we've got the 2 MOSFETs. Let's see if this will focus. Yep, I think it will. Get some light over here. We have the 2 MOSFETs. One here, one here. So these will be the 2 transformer windings, and this is the common. This will be our ground. This one goes to ground. I forget. I think, oh, these are for asynchronous operation. Or no, excuse me, synchronous operation. You got a couple of diodes that get involved in the circuit. And this doesn't have everything populated on it for that operation, but this is what these would be for, and this would be the enable pin if you had a military style that needed an enable pin. And again, the board's not populated for those. But we've got a MOSFET for this winding, a MOSFET for this winding, and our common ground. On our vibrator base, if we're looking at it like so, with the 2 small pins down, we've got transformer winding 1, transformer winding 2, and this is our ground pin. This one's unused. They don't use this pin at all. So from the other side it would look like that. Transformer, transformer, ground. And what I'm going to do is just bend the wires around so that this little unit sits here, excuse me. And when I get that soldered together, rather than trying to fumble in front of the camera, I'll show you what it looks like. Okay, we've got transformer winding 1, transformer winding 2, and then from around in the back we came around behind and back up here. This is our ground pin from that one large diameter pin that's here. That's our ground, and we bent everything around as we did this to try to keep it more or less centered, so that when the can goes on, this will be not touching the sides. Now, it wouldn't really matter. There's nothing electrical there. That's just how I like to do it. But that's number 16 bus wire. It's very, very rugged. That's never going to go anywhere. That's not going to shake loose. It's not going to vibrate loose. That thing is just as solid as can be. Number 16 is actually a fairly stiff bus wire, especially in lengths that short. So I'm going to put this in the can, and then we'll put the unit into the radio, and we'll see what the B Plus looks like. And for those who haven't seen it, please excuse the dehumidifier running in the background. To roll this edge back over, just put a block of wood in the vise, and you just roll it around while applying some force. Be careful not to bend the pins. And I stole this from David Tipton, plagiarizing his move. For those who haven't seen it, go over to Dave's channel, Dave's Radio Adventures, and you talk about somebody who goes the extra 3 miles to get the job done. David does some amazing work, and I'm sure he'll appreciate more subscribers and viewers. So that's Dave's Radio Adventures, David Tipton. He does marvelous work. But this is all there is to rolling this edge. It's just push it up against the wood, and eventually this edge will completely capture. It's already captured it, but it'll tighten right up on it. And again, just be careful that you don't damage the pins doing this. Nothing very difficult here. And it's starting to tighten up. And when you get done, nobody will ever know this can's been opened. And that's why I'll put a mark on it to say it's got a solid state vibrator, because somebody would pull that out and say, well, this has to be dying soon, it's an old vibrator. But they won't be able to really tell that this has ever been opened up. Okay, that's what we're going to do. And there's the finished product. Hardly tell it isn't factory. And this thing's in tight. It won't rotate. It's in there solidly. And we've put a label on there, solid state conversion, and a date. And as soon as the paint's dry, I'll pull that thing back over to the bench. We'll pull the masking off and check our B plus voltage. Alrighty, we have the solid state vibrator in there, and it is performing exceptionally well. I've now got about 245 volts on the anodes. The B plus actually came up with this vibrator above. Well, you got to figure mine's not running right anyway. So we've gained voltage here. We've gone from about 205, we're up to 245 at this point. And it calls for 220 at the rectifier, and it calls for 215 at the anodes. And at the anodes, we're running a good 15-20 volts higher than that. So this vibrator is doing a beautiful job. Absolutely fantastic. Oh, and as a side benefit, listen to this. I'm going to tune off the station here.
Green Beret, Army Special.
You hear static. You know, that's normal AM background static, but zero, and I mean zero vibrator hash. I think they've changed something. The first couple of these I used, they had a little bit of buzz in the background from the vibrator. This one's absolutely silent. I think they may have tweaked their firmware on that chip a little bit. It is just silent.
Or my newest creation.
Yeah, absolutely beautiful. I can't get over how well this vibrator's working. So we're gonna, as soon as the paint's dry, it's not dry right now. I've got it up on standoff so that it's not sitting on the desk. I stuck some rubber feet under here and put a couple bolts in the mounting tabs. The paint's still just a little bit too soft to set it down. So I'm gonna let that harden up overnight. We'll put the covers on it and tie a bow on this one.
Ethos.com. That's
And we didn't show you this yet. There's the tone control, red, yellow, and then it goes into just the purple. The back. Ooh, sorry, had a cramp. Remember the backlight, the lamps have a purple filter on them, not very bright, but when you turn this to the yellow and then to the red on the tone control,
Code Sean, SEAN.
kind of interesting.
Experience into the experience of a lifetime. Be an AARP New Hampshire volunteer and advocate for change in your community.
And the power of...
Okay, we're going to wrap this up. This is what the set looks like all finished up. Now, a couple of notes for the owner, Matt. When you get this set and you put it in the car, there's a little chrome button right here where the antenna, near the antenna connector. This is the antenna connector. There's a little chrome button right there. You have to pop that open, warm the radio up, and tune it to a station near 1400. And then go in there with a small screwdriver, and there's an adjustment inside of here, and just turn it for peak signal. And that's something that, again, has to be done in the car. It has to be done with your antenna and in the car when the set, when the set's installed and the antenna's on the body, because this antenna is not mounted on a steel body, so it's going to have a different capacitance. And while I did set it up with the recommended capacitance to ground, it's not going to be exactly perfect. And it's real easy to do. You just pop this thing open, tune this to a station near 1400, and just turn that back and forth until you have the peak signal, and you're done. It's real simple to do. Before you put it in, you want to take your antenna connector here and take an ohm meter or a test light from this center pin and the antenna shaft itself, the actual antenna shaft. I'm hoping this is in frame. There it is. This is this is an automobile antenna, but it's not mounted on a car, so it's going to have a different impedance, different capacitance. But you want to have continuity from the tip of this thing to that antenna. There should be electrical continuity between those two. And there should be no continuity between the shell and here. There should, that would be a short circuit. That means something was wrong with the antenna internally. So from here to here should be nothing, but from this tip to the antenna shaft itself should have continuity. And the reason I want you to do that is there's a tiny fine wire that runs down the center of this, and it's very common for them to get broken. People grab this thing, instead of pulling it out here, they yank it out by the coax, and that fine wire gets broken. And if that's broken, you won't have any reception. So check that, and as long as that's good, you should be ready to rock and roll here.
Yeah. That Escalade is actually really...
We've got a little paint on there. I'm waiting for it to dry. It's going to take a couple of days. This is what, the 18th, I think.
Not real money to buy.
So probably end of the week, the paint will be hard enough to box this thing up and ship it down to you. And that's going to wrap this one up. I'll be in contact with you. And I hope you're happy with it. Oh, all of your tubes are in the box. Didn't need any of them. The tubes that are in here are absolutely fine. You can tell the set's playing absolutely fine. Keep those for spares. You never know. These are, 60-year-old, 70-year-old tubes. There's no saying when one of them might fail. So, even though they're perfectly fine right now. Okay, that wraps this up. I'm the radio mechanic. I hope somebody found some of this information helpful. Remember Pico RF if you need a vibrator, and again, they're not a sponsor, just an excellent product. The best ones I've found so far. Take care, stay healthy, see you in the next one.